Hello, Mr. Chris Mayer. I am
Hello.
Enes Tigen, the captain of the Ege Aerospace team. We have get here to present the video safety review of our team. We are currently in our workshop at Ege University. With your permission, I would like to begin the presentation.
Of course.
We can adding to my flyer of records, Jasper Barnett. For the past 3 years, we have been working on developing sounding rockets at Ege University. We have achieved warrior success in national competition. Our aim is to enable university students to apply their engineering skills, particularly during their academic careers. Our team consists of 9 members specializing in avionics and mechanical fields, while 3 students work on avionics system, 3 other work on mechanical system. I also serve as the captain of the team focusing on mechanical system, while our advisor Barış Oğuz Gürses supports the avionics team. The progress of our project is currently proceeding smoothly. We have submitted progress reports on time and in full. We have completed all necessary payments for the computation and submitted our project technical report last week. We have worked as a team throughout all projects and strive to conduct professional project management. We have learned valuable lessons in project management along the way. Now, I would like to move on the general details of our project. We base our development on the model sounding rocket on 9 main components. We will share with you these parts are their location within the rocket in the presentation. Except for the motor, we have developed all parts ourselves and present them to you in asset category, which we are the proud of. We can examine into integrity of the rocket in 5 different sections. The main parachute, ejection system, avionics system, payload system, and motor section. We will share the placement of this section within the rocket with you during the presentation. During operation, we will execute 2 different separations. The first separation will occur at the apogee point, where our aim is to release the payload. The payload will descend with its parachute and collect data. The second separation will occur upon reaching the designated altitude, where the main parachute will be deployed for the rocket's recovery. We will share the details of the separation system with you on the subscan page on the presentation. We conducted the concept design of the system using the OpenRocket application. From the presentation screen, you can see the version of our rocket and the data we obtained from the application. We are using the M2500T motor developed by Aerotech as our motor. We purchased our motor from Whiteman Rocketry as recommended by the competition and will receive it upon arrival in the USA. We calculate our target altitude to be 10,000 feet. Within an allowance of approximately 300 feet. We share its flight parameters such as velocity and acceleration of the system on the presentation screen, which we obtained in accordance with the DTEC specification. On this page, you can see the concept design of the rocket system. The assembly of rockets presented on the initial page has been added as input data to the Open Rocket program. The weight of the system has been determined in real life, and a mass budget has been created. The data determined in this mass budget has been entered to Open Rocket. We analyzed the flight operation in 8 different stages. Each stage indicates a step. The first stage is for the rocket to reach the launch pad and complete pre-launch checklist. In the second stage, we aim to place the rocket on the launch pad and ignite it. The rocket will ascend. We analyzed the ascent in 2 different stages. Stage 3 is the piece where the motor continues to burn. Stage 4 is defined as the stage where the motor burn ends and the rocket ascent continues. The subsequent stage, stage 5, is when the rocket's thrust ends and its acceleration reach 0. This point corresponds to the apogee points. The first separation system will occur in the stage realizing the payload. The rocket will then enter free fall. When approximately 1,500 feet is reached, stage 6 will come into play. The second separation will occur and the main parachute will deploy. The system will descend attached to their parachute, and stage 7 will proceed. Then the final stage 8 will come into play and recovery will take place. Okay, the presentation will progress under the headings of aerostructures, internal parts, payload, avionics. You continue.
Okay. Okay. I have a couple of questions. I saw you indicated you had your launch rail velocity and you had your Mach number. So Mach 0.8, almost Mach 0.9, right?
Yes.
Yeah. Okay. That's good. One of the things that people don't put on this whole evaluation, I saw the list of things that you're going to cover. And one of the things that's missing, in my opinion, is the rail buttons. The rail buttons are pretty important to keep the rocket on the pad.
Yes, we have them actually. One is attached and the other one is not. I can show you on the mobile camera.
Okay, so one of the challenges with a presentation and then a video is that the video you're showing me now is a tiny little 1 centimeter square box. So
you can click on it and it will take the whole screen, I hope.
Well, not quite, but yes, it gets bigger. I got it sorted. Okay, I can see that better.
Okay.
Did you purchase these rail buttons?
These are not purchased, but we will purchase our actual flight rail buttons.
Yeah, they're like $5. They're super
Yeah,
cheap.
Yeah. Plus,
Okay.
I believe we have one which is not connected. My teammates are preparing them.
How many rail buttons do you have on the rocket?
We have 2 rail buttons. One is located here, and the other one is on the other upper body. As you can see,
just put your finger. Yeah, put your finger on the rocket where that rail button will be.
This one.
Way up there. Okay.
yes.
So now, how long is your launch rail?
Yeah, we are going to be using the extra provided launch rail, which I believe is 17 feet.
17 feet. But you've got at least 1 meter, maybe 1.5 meters between those rail buttons, correct?
I think so. Yes. Yes.
I mean, approximately. Just so here's the challenge with that, because one meter is approximately 3 feet. Okay.
Yes.
So what you have effectively done is shortened your launch rail, right? Because as soon as the first rail button exits the rail, you no longer have static stability provided by the rail, correct? Okay.
Yes, sure.
So that's a very important thing. Now, I like that aluminum chunk that you had with a bolt screwed straight into it. That seems like a fairly secure method to attach a rail button.
Yes. Also, the other rail button is attached to our motor retainer bulkhead. No, our centering ring. Excuse me. Can you see the centering ring is the third one from the bottom?
Yep. I can.
All of our rail buttons are screwed onto our bulkheads.
Yes. Now, are those metric threads that you're using there?
Yes.
Okay.
These are metric 4 and these are metric 6.
So one of the reasons that we worry about the rail buttons, and I don't want to say we get grumpy about it. What happens is people come out there with rail buttons that they have manufactured.
Mm-hmm.
And I can tell you the aluminum rail buttons will not be allowed. Okay.
Okay.
But Delrun, what I worry about is, like, look at the head of your screw on the rail button. Okay. Look at it very closely. It protrudes, right? It's above.
Yes. Because,
yes. And that can cause a problem on the rail.
Yes, we are aware of that. It's a temporary solution for now.
Right.
We are going to be replacing these bolts.
Okay, but when you buy rail buttons, the rail buttons that you purchase typically have a chamfer, right? An angle. And then the screw head fits into the rail button so that the screw does not protrude.
Yes.
But the rail buttons that you will be able to purchase, at least in the United States, the bolts that they come with are going to be not metric.
Yes.
Okay. So anyway, what I'm trying to do here is make sure that you guys don't get to the United States and then have something really simple like a rail button make it very difficult for you to fly your rocket.
Okay. We'll actually remember that, because that's actually a crucial point.
Yeah, as simple as those things are, that is, as you pointed out, a crucial point.
Yes.
Okay, so make sure that you have accounted for the length between your rail buttons in your speed calculations and your stability calculations, because that will come up in your on-site flight safety review, right?
Yes.
Okay. Have you guys participated before? Have you been to the United States?
No, this is our first year actually.
Your first year. Okay.
But we previously have competed in the national Technofest competition.
Okay. Well, I have some information to share with you at some point along the way to let you know kind of, I'm happy to share it if you don't want it, and I won't necessarily force it on you, but I'm happy to share kind of the process and procedure and what goes on when you get here. Okay, so rail buttons are important. And part of that process and procedure is going to be when you bring your rocket to the event, right? There's a 2-day convention center event before we go to a different location to fly the rockets, all right?
Yes.
And that during that 2 to 3 day convention center portion of the event, there will be a hands-on safety inspection where people actually touch your rocket, have you
Yes.
bring it in and fix it. Okay. And
You know.
many of the things that I'm going to ask you now, they're going to ask you again. And so if I'm questioning it and if I'm making a point about it, I would highly recommend that you either take some good notes now or come back to the video and watch it and then write down your notes. So what I'm trying to get, again, I'm trying to make sure that you guys have the highest probability of successfully flying your rocket, right? We want you guys to come and have a good time and fly a rocket, right? We are not here to try to make it where you can't fly the rocket, but we do need you to be able to come and fly the rocket safely. Okay.
Yes.
All right. I think enough. So the other rail button you said is bolted into that aluminum fin carrier,
Yes.
correct?
This is actually a part of our recovery system. We attach a metric 8 eye bolts here, and it also serves as a baffle bulkhead, preventing any black powder combustion products from reaching our parachutes by capturing them.
Okay. Are you using CO2 or black powder? What'd you say?
We're using black powder.
Black powder. Okay. You have a flame bag. Yeah.
And this is our flame protection.
I actually have a question about that that eye bolt that you just showed.
Okay.
Is there any on the opposite side? Is that just threaded directly into the bulkhead?
It is directly threaded into the bulkhead, but we are going to be using a Loctite thread locking.
Okay.
Compound.
I would recommend if you have the ability to get some sort of mechanical thread lock as well, that you do that, because even the quote unquote permanent Loctite is not permanent. And I have seen I've seen eye bolts like that have
They'll spin out.
unscrewed themselves in flight.
One of the other things you can do is you know there's a number of ways to solve this, and this is exactly the kind of thing that the safety reviewer is going to go over with you. You could put another small hole and put a separate, you know, attachment bolt, another little a smaller eye bolt between your two, any one of those big holes that you've got, and then you just tie a string. You just tie a piece of Kevlar cord or something through both of the eye bolts, and then it can't unwind if it comes loose. Okay, so that's one form of mechanical. But that's the type of thing that Jasper and myself and the safety reviewers on site, that's the type of thing they're going to look for as a preferred method.
Okay, we'll definitely place more, secure this more secure. You can move on if you want, or if you have other questions, I can answer it. I'll answer them.
No, by all means, move on.
Okay, so we have our motor retention bulkhead here, and then we have our coupler here. Would you like us
I would like to see the coupler. Yes, please. Yes. The rocket parts, the tubes and the couplers and the nose cone, I saw a mold. So have you guys manufactured all of these tubes and things, or have you purchased some of it?
We have manufactured all of our fiberglass parts.
Okay.
Else, going to be removing that. Okay. So this is our coupler.
All right. Which side of that coupler is bolted in versus which side separates to allow the parachute out?
This side is bolted to our upper body. We also have that baffle bulkhead I mentioned before. Here.
Okay. That's a baffle. Okay. What? How many winds of? You said it's fiberglass or carbon fiber?
Fiberglass.
Fiberglass.
It's coated with gel coat because we can. Yeah, it provides us a more better surface for the fit between the airframe.
Okay.
How much of the section of that coupler that separates in flight, what's the length of that is in the airframe tube? How much total engagement length do you have there?
So our the outer diameter of our body tubes are 155
No,
millimeter.
lengthwise, not diameter wise.
Yes, I'm going to explain that shortly. So indeed, it is mentioned that it has to be like 1 caliber, I believe.
Yeah.
So
One caliber.
The total length of our coupler tube is twice the diameter of our rocket. So it's approximately like more than 30 centimeters.
Okay.
Can you show us, like, you showed me the end that bolts in to
Yes.
the one part of the rocket. Can you simulate approximately the distance that the other piece goes into the rocket? Like show us just the coupler and the joint that separates.
Approximately
Now that's the bolt-in one. I want to
Yeah,
see
the
the joint
other
that
side.
separates.
like this. Achievement.
Okay.
Okay.
Okay. Yeah,
And
looks
that
pretty-
band, that little line on there, it's a silver band. That's
This tape, just masking
tape.
tape.
Okay. All right.
Increase.
That's friction tape. Okay.
Yes.
Okay. I'm good. Jasper, you all right?
Yeah, I'm good.
All right. Thank you.
And this is
You
our,
are. Yeah, there's the nose cone. Is that glued in, that
Oh,
piece?
which piece?
Into the coupler, is it glued into the nose cone?
Yes, it's glued.
Okay.
Epoxy. Yeah, with an epoxy.
All right.
Okay.
Plus, our bulkhead is also glued to our coupler with a two-part epoxy adhesive.
Gotcha. Less of a concern there for that to spin out, that but those eye bolts, they're really notoriously bad about unscrewing themselves at the most inopportune times. So
that
just-
is the truth.
Okay.
if I could count, if I had $1 for every time that somebody said, "Oh, that'll be fine," and then it unscrewed itself, like I'd have quite a pile of money.
I have enough to fund one of these teams, probably.
Probably. Okay.
That,
All right.
that's
I'm
yeah,
I'm
that's
good.
definitely-
So the bulkhead is glued into that nose cone, so it's just an empty nose cone. There's nothing up in the top of it.
Yes.
Okay.
Okay.
Exactly.
All right.
Hey, all right. This is our body tube. And the other one. This is the upper one. This is the lower one.
Okay.
Okay.
I can move on to our ejection system if you want.
Actually, I'd like to take a look at the fins first.
Okay.
Yeah.
Yeah, fins and how those are attached. Okay, so
They're
So the-
aluminum fins, right?
Yes, they're 5 millimeter laser cut aluminum films.
Yeah. Yeah. I've seen this before, and we talked about this early on. You know, show inside the fin can. That the one challenge. Do you have 2 or 3 of those supports?
We have 2 of them.
2. You have no center support, and the only thing, yeah, the only thing I worry about is that the ear on the one side, there's not a lot of aluminum backing it up. Yeah, right there.
Yes, we did an ANSYS analysis and finite element analysis and provided the results on, I believe, on our second progress report about that.
Yeah.
That was a previous concern you mailed about us.
Yes. Well, you're also a subsonic rocket, right? And you've got pretty
Yes.
large fins. I do worry about it landing hard, and you especially with that particular fin design, because the fins stick out past the bottom of the rocket. But that's not for me to really.
Yeah.
There'll be other points deducted if your rocket is damaged upon landing.
Mhm.
It's not so that's not
It's
so
not-
much of a safety issue in flight.
Right. It's not that is not a flight safety challenge per se. Now, I will say that the fact that you've got aluminum fins that are pointy hanging off the back of the rocket like that,
Mhm.
that could be a little dangerous if it comes down in a suboptimal area, right?
Mhm. Mhm.
So
Yes.
if it lands in the middle of the desert, great. It's only going to hurt cactus and sand. But okay. You good with the fins there, Jasper?
How are the centering rings secured into the airframe?
And they're
Are they
all
just bolted
bolted.
in as well?
Yes, they are bolted with
Okay.
metric 6 bolts.
6 bolts. Okay.
How many bolts total? Looks like at least 8.
4 on our centering rings and 8 on our motor retention bulkhead.
Okay.
Okay.
So 8 on the bulkhead and then 4 on each of those centering rings for a total of 8 holding the fins in. Yeah, I think I'm happy with that.
Okay.
Yeah, the motor's being retained separately.
Okay.
Where else would you like to go? How about you go to how are you attaching the harness and the motor to this assembly here?
Okay. Let me show you the other side of our motor retention bulkhead. We have another threaded hole for an M10 eye-bolt there. So we are attaching the recovery harnesses to that eye-bolt. It is not bolted right now, but we are going to be bolting an M10 eye-bolt there.
Okay. And
Okay.
so I see a hole or something down there.
Yes, that's
You-
actually the I removed that. This is a PLA printed
Oh.
seal for our recovery testing. We are not going to be flying with
Okay.
this,
Okay.
only for testing.
Ah,
The forward closure of the motor is going to be protruding from there.
All right. And then the second hole, the smaller hole, what does it do?
The smaller hole is for the eye bolt.
Oh, so it's off center, so it's not going to spin. Okay.
well, just because it's off center doesn't mean it won't spin.
Yeah, that's true.
Especially with those big fins.
Yeah.
That's probably the one that I'd be most concerned about spinning.
Yep.
But it's also probably the one where it's easiest to get in
fix.
from the other side and put a second.
Some other form of retention. Yeah. Some mechanical lock of some sort to keep the bolt
Okay.
from spinning off the top of the Aerotech motor, right?
Or just put it through an eye bolt on the forward closure of the motor as well as through the eye bolt into that
Yep.
M10 hole.
Yes, we also think about doing that, but we don't have the exact dimensional information about our motor case. That's why we decided to do this.
Okay. Okay, that's pretty tricky. But you can probably then get a piece of all thread or something, and when you arrive, you can create a second eye bolt in the motor, and then again just tie them together, and then neither one of them will be able to spin.
Yeah, that's actually a great advice and a great solution. We'll definitely consider that.
I think the 20 or the 98 10 240s, the threaded forward closure, I think those are 316 whatever the fine pitch.
16th, yeah. So they're, yes, unfortunately they're not
creates
metric. They're not metric, but the parts that you will need are readily available on the internet if you want to procure them ahead of time. And in fact, the parts that you might need are probably available in Las Cruces at one of the, we call it Home Depot, but or some sort of hardware / home improvement store that has bolts and nuts and things that you could probably use to secure it.
Okay.
And the specifications you can probably get off of the Aerotech website.
Okay,
I actually
we'll
don't
check.
think that they have the dimensions for the
threads,
mechanical
really? Oh my gosh.
closures. It's one of those things that is, I know it's for some sizes they do, and for other sizes they don't list
Okay.
what the threads are.
Do you guys, how are you doing? So you have a motor ordered, procured? What are you doing for a motor?
We have ordered our motor, but it's going to be delivered to the event.
Okay.
To this America.
Does that
we
include
also-
the hardware? So you-
yes, both
okay.
the hardware and the reloads.
Okay. Who did you order it from?
We ordered it from Wildman Rocketry.
Wildman Rocketry. Outstanding.
Yes.
He's pretty good. He might be able to, if you emailed him, he may be able to give you the thread specifications that you need.
Oh, okay. Well, definitely email them then.
All right. So we've also covered something important. Then you've got a motor ordered, paid for. You've got a case to put it in. You have it from a
Yes.
vendor who's going to bring it to the site.
Yes.
I'm going to go ahead and then slip in another one of those little details, and you'll hear me say it again, but energetics, black powder, and the motor grains themselves are not to be brought into the convention center.
Okay.
Okay. Keep that, just
Okay.
make sure you know that. Also pay attention to whatever hotel or, if you rented a house or whatever accommodations you were staying in, they may have explicitly said some of that type of stuff too. So don't pay attention to that and don't have that be a problem. Okay.
I don't know if you're aware of it, Chris, but there was an incident at, I believe it was NSL West last year with a
The
student.
J motor.
I don't know if it was with something in a hotel room.
Yes. Yeah.
Yeah. I don't recall the exact details of how big the motor was, but yeah, my strong recommendation is, regardless of what the place says, don't bring energetics into.
Yeah.
into
don't bring energetics into your house.
Yeah.
Okay. We are not going to be shipping our black powder from here.
Or you'll be buying?
Yes, we are going to be buying or somehow getting it in the US.
Okay.
It would be very difficult for us to get that from the airport security.
Yeah.
Yes, that is true. Can you get black powder there to perform an ejection charge test?
I think we can. We should be able to. We have
You guys have already done an ejection charge test, right?
Yes, we did.
Okay. All right. What else? What else we need to look at here?
What else? I can show you our ejection.
Well, yeah. Look at that. It's been tested.
As you can see, we have definitely tested with it before. So this is our charge valve.
Wow.
For redundancy.
So you have an armed charge well right there.
No, it's not armed. It's just tape. There's no black powder in it.
Okay.
I just taped
so
it.
So exactly what you just did there. My team wants to bring in a mock motor. Okay. And so anybody that sees that is going to assume that has black powder in it. And so I would highly recommend some sort of a big label or some, writing on the thing that says inert, right?
Yeah. Normally we are going to be taping the ends just before launch.
Yes,
So
but I'm
this
just
is
saying
only
if
for demonstration purpose.
demonstration. So, but what I'm
Okay.
getting at is if you had that in the convention center,
Mhm,
people would think that you had black powder in that
mhm.
because you don't have it. You don't have markings on it that say inert or demonstration or something. Okay. So if you're going to bring that into the convention center, make sure it's labeled well that it is inert, no black powder or something. Okay.
Okay. I can move on if you want.
Okay.
If you don't have any other
I think the one
questions.
thing that I would like to take a look at is the avionics bay.
Our avionics bay is here.
Okay. So I know that I mentioned recently when I was talking with you that I think you really need to have a second COTS altimeter on there.
Yes.
You only have one COTS altimeter.
Yes, we have only one.
Yeah, I think you really should, based on the fact that your custom board has not had flight testing performed on it yet. I think
No.
I would
Yeah,
not be comfortable having it as a method of ejection charge testing or ejection charge firing during flight
Yes.
when it has not been
We
flight
didn't
tested.
test it, yeah.
You will test it. So I think what he's worried about is that you flown that in a rocket before? That computer.
No, we have not flown our
Okay.
SRAT flight computer before.
And so what your flyer of record is telling you is that he does not want to fly that rocket unless you have two COTS electronics and a third electronic being your SRAT.
Okay,
Because
so
it hasn't been flight tested. If you had
yes.
flown it and you had proven that it works, he might be a little more comfortable with that.
As someone who's developed quite a bit of those sorts of things, it's they never work the first time. They never work right the first time.
And so in the United States, our military has this saying, one is none, two is one. All right. And so right now, basically, in our opinion, you have exactly one reliable flight computer. And so with that mentality, one is none. So you have no computer, right? Like, because it will break. Like that's just the way things unfortunately work.
Okay, so if we
You have room? Can you flip it over?
we could probably fit another one
Oh
there.
yeah, you have plenty of
Is
space.
it okay if we use another RRC3 or is it supposed to be a different model?
So
or
here's where I land on that. And this is up to you to decide and for you and your flyer of record to work out between the two of you. But again, even if you've got very reliable RRC3, okay, if you experience a particular type of failure that exposes a bug in the RRC3, whatever that bug may be, it may be a flight dynamic thing where the rocket hits the wind shear, or the vent holes do something weird or whatever. If you have two of the exact same thing, or if there's heat and the heat damages the batteries, right, or causes the system to overheat, right? If one of your systems experiences that error condition, the probability that an identical system will experience an identical error is pretty high. Okay, so personally, I don't like to fly two of the exact same thing. However,
in mind.
yeah. So, however, it is not wrong to fly two of the same thing. And one of the things I worry about is I don't want you to then have to pick a flight computer you have never used before, because the probability of failure goes up significantly if you haven't had a chance to actually fly it and get to know how the electronics work. So that is actually a great question then. Have you guys flown RRC3s before?
We used RRC3 and we tested it in vacuum oven, or we put it yani fırlattık. Daha önce elimizde ama
Okay, so
but we didn't any flight tests.
Okay.
With
You've,
that,
you've,
or,
you've not had experience flying that in another rocket.
yes.
Yes.
We have
Okay.
no.
I mean, look, I like your selection. That's a pretty good selection personally, because RRC3s are pretty, you have to work at making them not work. And they're actually pretty friendly because you can use not a computer. You can put the little display screen on and configure them, right? They're very user friendly from that perspective. But I do always like to make sure that you're very familiar with all of the features and the functionality, and preferably you've had an opportunity to fly at least 1 or 2 rockets with that flight computer.
Okay. Unfortunately, we have no experience about.
Okay. All right. Well, that is not something that prevents you from flying the thing, but that is an indication that you and your flyer of record should huddle ahead of time and make sure that everybody's comfortable with the way it's configured and the parameters. And okay.
Yeah.
Okay.
And I'll second what Chris was saying, is that the RRC3 is a good choice for if you have to fly with something you haven't flown before.
Okay. We designed it very carefully, but if you say that's okay, we will change. Yeah.
So designed carefully is not, I have tested it and know it works, right?
Yeah.
And look, so when I evaluate a rocket, I look at it, can I hang it on the rail safely, and will it get up the rail stable? Does it come off the pad with, you've showed me your margin of stability, your feet per second, right? So now I know I've got a rocket and it's going up, right? and I'm going to keep the pointy end pointed up, right? That's an important piece. I'm looking at the couplers then, like how fast are you going to go and what are the dynamic forces? Is the rocket going to fold in half, or is it going to survive the flight? I think you've kind of demonstrated pretty well that. If you've done those 2 things, then there's a really critical thing that needs to freaking happen. Okay. When that rocket reaches apogee, it has to be rendered aerodynamically unviable. Because if it's not, you've got, a nearly Mach 1 ballistic missile. Okay. Humans cannot see, hear, or step out of the way of that. If you pop the rocket in half, at least it will tumble back to Earth. It may come back quickly if the main parachute, if everything else fails after that, at least the rocket comes back and humans can probably see it, and they have at least some opportunity to move out of the way and not let, okay? So this is why we're making a big deal out of these electronics, is it really has to come apart at apogee.
Yeah.
Okay.
The line that my mentor would use was, flying is optional, landing is mandatory.
Okay. Then we will cut the cables going to the igniters from the
cable routing. That
from
makes
the
sense.
flight computer.
What are the other question I have? So the other 2 follow-up questions regarding the avionics are with regards to the battery, and so what battery are you using, and what are you using as an arming switch?
We're using. Can you switch getirebilir misin? We're using an LG battery here, and it's
Lithium-ion almost.
this is not lithium ion
It is a lithium
battery. Yeah, this is. I'm sorry. I'm confused.
We are a little bit nervous.
This is a lion.
Yeah, lithium.
Lithium-ion,
ion?
yes.
Okay.
Battery. I just understand it's like you're asking me it's lipo or something else, and no, it's not a lipo pill. It's a battery. It's just 3,500 milli
Milliamp hours.
milliampere hours battery here.
Yeah, that's
we,
plenty.
We have.
That'll power that altimeter for a week.
Yeah.
Yeah, we're using it for just these altimeters RS3, and we're just using 1S for supplying the RS3, and we're using the other battery here. We're using 3S battery here. Like this battery is same battery here, and
Okay.
we're using for supplying the SRED flight computer and the telemetry card here. The telemetry card has the SA818 model behind that, and we are using this switch here. This is a
Okay, the key switch.
yes, this is we are using here.
Okay.
How are you going to do that from outside the rocket?
We're going to be cutting a access hatch outside where our avionics are located. We haven't done that yet, but we are going to be doing it in the coming weeks.
Is that going to compromise your structural integrity there?
We don't think so. Additionally,
If the hatch is the hatch only going to be in part of the airframe where you also have a coupler underneath it?
The coupler, actually, the hatch is going to be around here,
Okay.
and our couplers are up there.
Okay.
There and down below.
So how do you plan to secure the hatch in place? What's going to hold the hatch in place in flight?
We are going to be using bolts to secure that hatch, the door.
What are the bolts going to be attached to?
We can attach them to our. We haven't dialed in the design yet, but we can probably attach them to these bulkheads. If these are not suitable, we can switch to an aluminum bulkhead.
Yeah, I think.
You have a bolt that goes all the way through that then?
Which side? Which one? Which bolt?
So where does one of the things that I think we're going to need to see is the harness, the entire. So one of the things that's going to happen at the flight safety review is you have to bring the rocket in completely assembled and ready to fly, right? Which will include all of your harnesses and your connectors and your U-bolts or I-bolts or whatever it is you're using, okay? And what that lets people do is look at what pieces are structural versus which pieces are non-structural. And I think what both Jasper and I are trying to look at right now is your eBay that you're holding in your hand, is that a structural item or is it a non-structural? I see those other two holes.
And this avionics bay is not structural. We are not going to be attaching any recovery harnesses to them. Our recovery harnesses.
So
for the go on.
Sorry, I'm not right now. I'm not so much concerned about whether the recovery harnesses are attached to that as if part of your airframe is depending on that structurally. Because if you have a hatch that's only connection to the rocket is through your avionics bay, then your avionics bay becomes structural to the integrity of the airframe.
Yes.
The tube, if you cut a hole, a big hole, especially if you cut a big hole in the tube, then the tube can bend right at where you cut that hatch. And so is that particular 3D printed item the thing that helps stiffen the place that you just cut your hole? That's what.
Okay, so our hole is not going to be very large. So
Okay. So
And we can-
look, the reason we're asking a lot of these questions, not trying to make you nervous. We're just again, we want to make sure that you can show up and have a high probability of flying the rocket safely. And
Okay.
so what a lot of people will do is they use a thing called a screw switch, right? That's
Mhm.
one option. And then you only have to drill a small little hole and you put a screwdriver through the airframe and you align your eBay with and the switch with that hole, and then you can turn it on or off, right? Or you put the key switch that you had is mounted to the airframe and the wires are then somehow connected. Like that's for you guys to figure out. But there's other ways to do this that don't require you to cut a great big hatch into your airframe, thereby weakening the airframe.
Okay.
I can send you some pictures of various different ways that I've done it in the past,
Yeah,
just to give
that
you some
would be
ideas.
very helpful. Thank you.
Okay.
Okay.
Are you good so far now on the eBay?
I think so.
Okay. And guys, the another there, I'm not trying to sell or recommend anything. We're not, but look around at the other flight computers, things like Perfect Flight and stuff like that. There are some other relatively inexpensive flight computers that are also pretty easy to set up and pretty user friendly that you can use, and they're usually pretty small and they run on something as small as a 9-volt battery. So the uplift to add a tertiary, a third flight computer where you have 2 redundant COTS flight computers and then your SRAD computer, that lift is probably not very big, and the amount of safety that you achieve is significant.
I agree.
Okay. Well,
The one thing I will say about Perfect Flight is that actually finding one of them can be tricky.
Yeah. Okay. So I see you got your CubeSat there, yes?
yes, this is our payload.
All right. Your payload, is it structural? Because I see you've got an eye bolt screwed into it.
No, that's only for the its parachutes.
That's for its parachute. It recovers independently. Okay.
Yes.
Now I've got a different question for you here, because you are required to have a tracker on the rocket, right?
Mm-hmm.
So what, and is that the SRAD? Is it an SRAD tracker that you've built, or are you flying some sort of featherweight tracker or?
We're using a threat tracker here, and this is we are using the GPS model as modeler here in our on our payload computer here, and there is some sensors to sending data to ground station, and yes, we're just using for the location.
Okay.
Okay.
And
I mean,
there will be a telemetry card for sending data to ground station.
okay. What are you using? Is it a ham radio band? Is it 900 megahertz? Like what frequency?
We're using like 4000s and 33 megahertz, and we can change it immediately if you want in area. We're using this SRAD telemetry card here, and we're testing so much in with a spectrum analyzer or another else test we did, and it's working actually very good. We can communicate with 6 kilometers and without any package loss. And,
I think the concern we're getting at is less about whether or not it will work, and more about what sections of the frequency spectrum you're allowed to use as an amateur in the U.S.
Yeah, so in the United
Hmm.
States, we have restrictions on which frequencies you can broadcast on.
And they're different from most of Europe. So yeah, so
We, well, yeah, we can change the frequency immediately, and
very easily.
we can handle it. I think.
All right,
I
so
think
so
I
do
can
this.
answer it.
Yeah. Well, so look, we don't need.
Actually, it can be adjusted at site, and we are aware that the frequency, a lot frequencies in America is different from Europe. Actually, two of our members have amateur radio license,
Perfect.
so
Oh,
Okay.
awesome.
I think we can manage to work it in the a lot frequencies at site.
All right. Yes. All right. I think
Okay.
we'll probably
Cool.
be okay then. That helps. The fact that
That
you've got
that
your
makes things much easier.
yes. Okay. And you have tracking. So here's the reason I'm asking you about tracking on your payload section. Is what one of the things we don't want to do is we'd like to be invited back to Spaceport, and leaving lots of rocket trash out in the desert is not the way we get invited back. So we want to make sure that you've got tracking on things so that you can go pick them up.
We're tracking everything, don't worry.
But you got tracking on both of those. Yeah.
Okay. So that pulls out independently.
Mhm.
Does it just fall out, or is it forced out by a spring, or
It's actually forced out by the shock cord we have.
By the
Okay.
ejection charge? Okay. Have you so my question then becomes, as someone who's done that before and had problems with it, have you done a
Mhm.
deployment test with your payload in place?
We did a deployment test with our payload
Without
in
it.
our rocket.
Okay. Because I know one of the things that I learned the hard way when I was in college was
Mhm.
that payloads tend to not like to get hit with huge amounts of forces
Mhm.
from ejection charges, and they tend to react to that by braking.
Mhm.
So I would recommend doing some testing of your deployment with the payload in place to make sure that the payload is capable of withstanding the forces of deployment.
Okay.
Which are a lot higher than you would think.
Yeah, we have experienced it before. Our payload is actually a very structurally sound. We are using, they are welded right now. They are not, but they are going to be welded, these plates,
oh wow.
and all everything is just welded in place. So our
Okay.
place is just steel. So
Okay. Yeah, because
Steel. Wow.
steel. Okay. Yeah, that now I'm a lot less concerned.
It'll hold together. So the only other
Yeah.
thing that you need to make sure that you are aware of and figure out with regard to, it comes out at apogee, right? So your drogue
Mhm.
parachute, is your drogue parachute behind that or in front of that? If that gets wedged in the tube and doesn't come out, does it inhibit your drogue parachute from being able to exit your vehicle?
We have considered that. Our drogue is actually behind our payload, but the payload also has an adapter that we are going to be making. So
it will be restricted in terms of its ability to move laterally within the airframe. There's going to be something to keep it from sort of getting wedged sideways.
yes.
Okay.
Okay.
Becomes a piston.
Yeah.
I would prefer that the drogue was in front of that, so that even if that gets stuck and doesn't come out, at least you have some semblance of a drogue parachute. I want to also make sure that you've got plenty of shock cord in front of that so that you can separate the rocket.
Yeah.
Right? What you don't want to do is you don't want to have the ejection charge fire and have the thing come apart maybe 6 inches and get stuck because that payload is in the way. All right.
Yes.
My concern with doing it the other way around with the drogue on the top side is that that can promote an issue where the drogue shroud lines get tangled in the payload.
Yep.
Which is something I've also seen before.
Yeah. So anyway, there's lots to consider there. You work with your flyer of record and y'all get that sorted out. But I think at a bare minimum, I want to make sure that the rocket has some shock cord above it.
Yeah.
So that it can come apart and separate significantly.
Yes.
Yeah, I agree.
I can move on, or if you have any other questions.
Nope, move on.
No, I think
Okay.
that's it in terms of...
So our ejection system, our recovery system, we have 5.5 grams for our drogue and 2.6 grams for our main parachute deploy.
Okay.
We are also using an O-ring around the bulkhead. You can see on the picture on the slide for sealing any ejection gases and improving the ejection.
Okay. Good. Yeah.
We also
so my question is, so if you're using 5.5 grams for the drogue, what's your plan as to how much to use for the backup for the drogue?
Our backup is also 5.5 for now, but our charge wells can hold more than 5.5 grams. So we
Okay,
can, we're probably going to put like 6 or 6.5 grams for our backup.
Yeah, that's
okay.
Good idea. Go up half a gram, maybe a gram on the backup. The difference between please separate and I was not asking.
Yeah. Okay.
Okay.
I actually have to run. Is there anything else that you need me for, Chris?
No, I just, typically I ask, is the flyer of record got any other questions or concerns?
Yeah.
Just y'all make sure you guys tie off, and sync, preferably before the event.
Yeah.
So that there's no major concerns, no surprises. Again, we're trying to avoid surprises the day of the launch or at the, at the event, because then sometimes it's really hard to adjust.
Yeah.
All right.
Thanks,
Talk
Jeff.
to you guys later. Take care.
Thank you. Bye.
By the way, I would like to.
gitti.
Okay.
Tamam, devam ediyoruz.
Okay. Can I continue with?
Yes. Yes, please.
Okay. This is our. I want to talk about our all electronics in the payload here. There is one computer here, and you can see, right? By the way.
Yes.
Okay. We will record the data with SD card module here. We didn't solder it right now. In this card, but the other cards we tested and can record, and we can get all the data from the sensors, and we prove it at the tests, videos, and the third technical report. We told it and we show it, and there is 2 3S batteries here, like our avionics, and one of them is for supplying the computer and the telemetry cards, and one of them is just for supplying the camera and transmitter here.
Oh,
And
neat.
one antenna here we are using for transmit the video data.
Oh yeah,
question?
video telemetry. Yes, the live.
Yes.
Yes.
FPV plane.
Very nice.
Yes. This is FPV.
FPV plane.
It's an FPV camera.
Camera.
Nice. Okay, cool.
Okay. We are using that, and we have a card here for power distribution for fixed cables with
Okay.
looking good.
So where's that antenna going to be? Is it going to be inside all of that metal?
Yes.
Yes,
But the
This
sides
is-
are open.
just GPS antenna will location placement here, and the other the antenna for telemetry will be here, and this is not metal also. The this is flexi. Okay. Yeah.
Acrylic.
Okay.
And there will be our camera antenna here, camera transmit antenna
Okay.
here. We're using.
Cool.
You can see the distances between the antennas here.
Yeah.
Okay. The telemetry antenna will be here. Right
I
now
gotcha.
there is no antenna.
There's no hole. Yeah, you haven't put a.
Yeah, we will do that. Yeah.
Okay.
And we tested also. We provided. We can. There is no any package loss any of that system here.
All right.
Okay.
Tamam,
Can-
Telefon var.
Okay. No. If you want me, I can talk you about our algorithm, but we didn't use, like you say, for separate.
Yes.
But we get all the data to with our ground station. Yeah, and we will compare the data, like what is RRC.
Yeah.
Apogee, what's RRC apogee? What separates? I can talk right now.
The ejection charge. Yeah. At apogee or not. Yeah.
I'm very tired.
I think he's trying to say we will try and our designed SRED's flight computer in the flight and compare it to telemetry values with the purchase codes
Yes.
flight computer, and actually it will get flight tested. So I think he was trying to tell us, right? Yes, he's very silent right now.
It's all right. It's all right. It's okay to be nervous, but I'm really not trying to make you nervous. All right, so let me think through this here. So we've talked about rail buttons, talked about fins, talked about couplers, talked about body tubes, talked about your harness, talked about your ejection charges. I mean, we've talked about the things that are important. I haven't seen you bring out parachutes and, are you using Kevlar cord? What size Kevlar are you using? That's one flame bag that's not nearly big
These
enough,
are
but these are
Parachutes are here.
okay.
We just hang them there. This is our main parachute, the orange one.
Are you going to just fold
Just
those
not-
up, or are you going to use deployment bags? What is
We are going to be folding them.
folding? Okay. You're going to need a bigger flame bag than that. Just telling you.
Yeah.
That-
This
That is not going to adequately protect your parachutes.
You can get a bigger bag.
Yes, you probably need a bigger one.
Okay.
It just looks pretty small, but What we worry about, look, when you fire those black powder charges, they will melt. Yeah, that's the, you need to look online. They call it a burrito, and there's a specific way. You need to talk to your flyer of record about how to properly pack a parachute. That will be completely insufficient to properly and adequately protect the nylon of your parachute from the ejection charge. Okay.
Okay.
What will happen is the ejection charge will fire. There's a huge fireball inside your tube, and it will melt the nylon cords and it'll burn holes through the parachutes, and then you will have a suboptimal recovery. Is that the recovery harness? What is it made out of?
Yes, that's the recovery harness. Is dynamo. This part, and this part is coated with a special coating.
Is it flame resistant or something?
Yeah, yes,
Yes, yes.
flame
Okay.
resistant.
Tested.
We have tested it before.
All right. Yeah, but those are the types of things, again, that they're going to want to know. Have you looked at tensile strength? How much does your rocket weigh? What's the strength of that cable? They're going to ask you a lot of those questions. Okay.
Okay.
And so make sure, here's what I don't want you to get there and then have to go buy additional shock cord and your flyer of record. He seems pretty involved and pretty on top of all of the things. I'm sure if you set up a time to talk through with him the recovery harnesses and whatever, he will get you in a good spot. Okay.
Okay.
So what does happen, look, is we get kids, we get teams show up, and they have, usually it's too small. It's super tiny little string that they want to use to hold this rocket together. And it's nylon. Nylon will also melt again, with the ejection charges. So you have to pack all of that and the parachute into the flame bag. And you need to have that flame bag cover everything multiple times. Okay, so it's really kind of one of these packing procedural things that you have to figure out. But sometimes the cords aren't long enough. So that's another thing. They want to make sure that has plenty of length to it. And there's some, as they call, rule of thumb, right? Some basic guidelines that is just a typical rocketry thing. Typically the rocketry, saying is that the shock cord should be 3 to 4 times the length of the rocket. Okay. So, and again, this is for you and your flyer of record to work out. So what happens is people show up and they don't have those types of things. They have the improper harness. And so then they end up having to pay, go to the vendor, buy the shock cords and then update them. And I'm trying to make sure that you guys, again, show up prepared and don't have to scramble at the last minute to make an adjustment. Okay.
Okay.
But that's pretty cool. You guys got a pretty neat little project going there.
Thank you.
I think, do you guys have questions for me?
Hey, questions?
I think we can ask that. We ask a question for the RF review, but haven't gotten any answer yet. So, what we should do? Can you tell us the direction?
You haven't got an RF review? Well, I think one of the things that we don't want to see is a 802.11, like a Wi-Fi 2 gigahertz bands. The reason for that is that we have a lot of RF stuff on site already, and the probability of you not being able to communicate with your stuff is high because the people that show up to host the event, help us host the event, they have big licenses where they're transmitting at, lots of, not even milliwatts, right? They're transmitting watts of power. And so it drowns out other people's RF stuff. Okay, so my suggestion is that make sure that you don't have anything that prevents you from flying that depends upon an RF signal. Okay.
Okay, thank you.
And otherwise, then there's just the coordination of frequencies for your packets. And if you've got ham radio licenses and things like that, that makes it easier. They have on the forum, I guess you've posted there and you have not gotten a response. Is that what you're saying?
Yeah. Yeah.
Okay. I will poke and prod some of the Ezra folks and see if we can get some folks to maybe respond to that. But it sounds like you've got most of the things you need based on the fact that you've got some ham radio operators on the team.
Yeah.
And then, okay. I think you guys are in better shape than most.
Oh, thank you. Very flattered.
Okay. If you have very specific things and you want to email me those specific questions, I will try to follow up and find somebody maybe get a better answer than what I've given you here. But remind, what specific thing you've got some RF questions, but I don't know exactly what those questions are. So that's what I'm asking you. Provide me some details. No, we don't have to do that right now. Follow up with me in an email or something. Okay. All right. What other questions you got?
I don't think we have any.
I'm sorry, I didn't hear that.
Sorry, I was muted. We don't have any other questions, and if we have, we can probably email you.
Okay, so you don't have any other questions. That's rare for somebody who hasn't been to the United States and not to the event before. So I'm going to give you some tips, pointers, and do you guys have your flights booked? You have paid for your airline tickets already?
Not yet. Actually, we have a visa reservation on Monday at the United States Consulate. After the visa results, we'll get our tickets.
Gotcha.
We try to book, but right now we're concerned about our visa. So
gotcha.
After the visa problem solved, we'll get our tickets.
Gotcha. Where are you guys, in Istanbul, or where are you?
İzmir.
Okay. All right. Okay, so you do have a visa thing that you got to sort out first. Because that was my next question, is do you have visas and things like that? Do you have hotels reserved? Do you have plane tickets? There's a lot of logistics like that go into this. Clearly, making sure you have a visa before you do some of the other things is probably important. So, okay. That's the logistics part there. I mean, the other thing to know is, like, you're coming to the desert, and I would imagine you may be familiar with that, but I guess you're laughing but the New Mexico desert is it can get hot.
Yeah. Yes, actually, Izmir is hot, but we are really concerned about the weather in the desert. So we are watching YouTube videos and read some forums about desert life.
Okay.
So any recommendation, we will be happy to hear.
Okay. So one of the questions that somebody from Spain asked me yesterday, which is a great question. A lot of people will buy something like, I'm not making a recommendation or an endorsement here by any stretch, but like Under Armour sells a thing they call compression, and it's a long sleeve shirt that fits fairly snugly, and then you can put your regular shirt over the top of it. And that is a great way to help mitigate having to manage sunscreen on your entire body, right? So sunscreen and protecting yourself from the sun, hats, bring nice big brimmed hats, right? Something like that. Of course, it's windy, so it may blow your hat off. But a long sleeve shirt that is very breathable is a great way to help mitigate getting sunburnt, as that won't be fun if you do that. And then obviously water and water and more water and more water and more water. And you're going to hear that again and again and again. We would really like to have an event where nobody suffers, from heat stroke. If you feel thirsty, it's already too late. You are way behind on water if you feel thirsty.
Okay, I got thirsty. I guess.
So what is that's like half a liter, right?
Mhm.
That's a half-liter bottle. So you're supposed to have a minimum of 1 liter per hour.
Oh
Oh,
God.
okay.
We will need a bigger car, I guess.
Yeah, so it's a lot of water. People don't realize that, and because it's dry, it's very arid. Then you don't sweat. You don't feel sweaty. Okay, you don't see sweat dripping off of you. It evaporates very quickly, and so you don't realize how much you've sweat and how much you're getting dehydrated. So my recommendation is have somebody on the team do the buddy system. Everybody should be watching their watch, and every
Okay.
30 minutes or something like that, you should be picking up a half a liter and drinking, right? Don't try to drink it all at one time. You'll definitely feel sick that way. You need to have smaller amounts of water more frequently. Okay.
Okay.
So water, Gatorade, any kind of fluid that helps hydrate you is the right thing to have. Have it frequently. The best way to know that you are on target and doing the right thing is you are visiting the porta potty. Okay. If
Mhm.
you're not visiting the porta potty several times a day, you're not drinking enough water.
Okay. Okay.
It's really not a complicated formula, but it's real easy to get over there, and other people start flying rockets and you want to watch those and you're working on your thing and you got one problem that you got to figure out, and then you forget to drink water. And that's how people get sick. That's how they get hurt. So we don't want that to happen. We want you to come over, have a good time, and do it safely. And drinking lots of water is a really big thing.
Oh, one more question. Are there any scorpions on the rocket site?
So there are all
Scorpions.
kinds of yes, there are all
Then.
kinds of creatures in the desert. But
Oh,
as per normal, the creature is far more scared of you than you are of it, and the creature hears
Okay.
you coming, and the creature is going to probably move out of the way.
okay.
The way you get in trouble with creatures is you go up and you poke at them
Okay.
and you try to take a selfie with it, and try to hold it because it's a cute little whatever. Don't do that. Just leave the creatures
Okay.
alone. If you
Okay.
leave the creatures alone, they are most likely going to leave you alone. All right.
Definitely, we will leave them alone.
Okay.
Definitely.
You just you do your thing and they'll do their thing, and you guys will have a great time together.
Okay.
Good, by not
Okay.
crossing
Okay.
paths. All right. So yes, there are creatures out there, but they're they're not going to bother you unless you're doing something to them. Now, there are times like if the rocket lands and it's a while before you go pick it up, they might go underneath the parachute because it's shady or something like that, right? So you want, I live in Texas, we have scorpions and stuff all over. And so pretty much everybody in Texas knows that if you're going to pick something up, you don't just immediately put your hand on it and grab it. You kick it with the foot, right? You kick the rock over and look underneath and make sure that something hasn't snuck under it, right? So you look a little more closely before you just grab it with your hands. Okay.
Okay. Okay. Then. Okay.
All right. We covered the no energetics in the convention center.
Yes.
And again, you
That's what I
tricked me.
noted.
You tricked me. You showed me something. And I was like, "What, does that got black powder?" And he's pointed it right at the camera. That didn't look safe. So make sure you got markings on something like
Okay. Okay.
it's okay to have that, but people are going to assume that it's armed and dangerous if you don't mark it otherwise. Okay.
Okay.
What else? We covered the water and stay hydrated. Please, one of the teams I talked to literally said, "Oh, we've got a person whose job it is out there at Spaceport is to keep track of time and make sure everyone drinks water." And so that's like their whole job at Spaceport. And that's great. Buddy system works too. If you think about water, announce to the team, "Hey, everybody thought about water? Who's not had some water? Everybody have some water," right? And everybody kind of does that. You'll probably be all right. Again, figure out your logistics for where you're staying. That's a big thing. So there's like a number 1 and number 2 injury at a rocket launch. All right. And we've already talked about they compete for the number 1 and number 2 slots. We've already talked about one, and that's water dehydration. Do you guys know what the number 2 injury inducing system is at a rocket launch, how people get hurt? It is not what you would think.
Oh, I think cutting, maybe bleeding, or
Nope. No.
what is it?
So where are your electronics mounted in your rocket?
It's in the middle of that thing. Oh,
Okay. So, no, I'm just,
Can you
how
see?
high up? How high up is it? Do you need a ladder?
falling from a stair, yeah.
Falling from a ladder.
From a stair, no, not technical. Okay, okay, I get it right now.
Yeah.
We will
So,
be careful.
so the thing is, some people have very tall rockets and they put the electronics way up high. There
Mhm.
are some ladders there available, but if you need a tall ladder, make sure that you've got the appropriately sized ladder, right? You're not supposed to stand on the very top rung of a ladder, right? And then you should always have at least one person holding the ladder if another person is on the ladder, at least one person, if not two, okay? And that will help alleviate any concerns. Now, some people engineer their rocket where they're like, no, we've got the tall guy here and he can reach the thing and we don't even need a ladder. Perfect, okay? And that might be your case, but
Oh, no, unfortunately, we're all short. Only one member is the tall one. No.
okay.
That's the problem.
Maybe you put your your electronic switches down low. I don't know. Okay.
I will definitely recommend that.
Okay. But yes, so just be cognizant of that. That is a one of the large injury categories at a rocket launch is people falling off a ladder. I don't know. I think I've covered everything else. So let me run through the process a little bit since you guys have not been there before. You're going to show up to the event, whatever day you guys have decided to travel, get your visas for, and all that kind of stuff. The event is in Las Cruces, New Mexico, for the convention center, where you're going to bring your rocket in. You're going to be able to set up. Going to be assigned. You're going to do a check-in process. If you are going to go out to the pad to help put the rocket on the pad, you need your Tripoli membership picture, photo, PDF, whatever, right? You're going to show that at check-in. They're going to give you badges associated with that. And then you're going to get assigned like a table, and that's where you're going to set up your rocket. And then the judges will come there. You're going to have to go schedule or get an appointment to have your rocket safety reviewed. And then that same process that we're doing here, but this is going to be 2 or 3 people touching the rocket, pulling it apart, and actually doing stuff, physically looking at things instead of just like we're doing. And they're going to go through it, fine tooth comb. If everything passes, you're going to get a flight card. If they find a couple of things they want you to fix, they're going to give you a remediation list, right? A couple of things that you got to go fix. You'll go fix those things. You'll bring the rocket back. You'll get those checked off. When you've got the whole list checked off, you'll get a flight card. The earliest opportunity to fly a rocket is Wednesday afternoon, presuming you've got your flight card and all the safety checks done, right? Let's pretend that there's no wind, and that's a bad assumption. And you decide you're going to fly Wednesday afternoon. So you're going to go now about an hour away from Las Cruces to the Spaceport site where the field is to fly the rocket. You will have to pass through a U.S. immigration station. So you may want to make sure you have your passports with you. Okay. Or if you guys do a passport card, I know the United States has like the actual book, and then they have like an ID that's a passport card or something. But anyway, make sure you've got that to show. They usually are pretty good about letting the Border Patrol folks know that we've got this event and there's going to be some folks from a lot of different countries coming through. But nonetheless, you have to pass through that to get to the Spaceport site. If you're staying in Las Cruces. When you get to the site, the launch site on Spaceport, there's a final check. So you've got your flight card. Now you're going to have energetics. You're going to put your black powder charges in your rocket. You're going to assemble your motor. You're going to put the whole thing together and make it actually ready to fly. And then you're going to take it to final review. And they're going to want to know about who helped you assemble the motor. And they're going to ask you a bunch of stuff that they couldn't do at the convention center. right?
Mhm.
They're going to check those things, and they're going to look at your flight card and make sure that everything still jives. And then they're going to they're going to assign you a queue number or whatever. They're going to kind of put you in a queue to get set up to go with a group out to the pad to put the rocket on the pad. So we kind of do it in a volley, or a group of people go out and set up a bunch of rockets, and then we fly a bunch of rockets, and we kind of do that mechanism. We try to. That's the typical. We don't do onesie twosies.
Mhm.
So there'll be some waiting, and some of that kind of stuff that you're gonna have to be patient. Be friendly, don't it's hot out there, everybody's tired, it's easy to be grumpy. Try to be friendly. And we ask everyone else to do the same. So that's the rough process in terms of like going out there. One of the other things, and they're going to go over all of this in much more detail and much better than I am. And so I'm giving you a very general look of this, not a Chris said this, and it's the final answer. That's not it at all. There's at the convention center, there's a flyers meeting that'll happen, right? So the flyer of record, the team lead, they will have to go to basically a flyer safety brief, and they're going to go over this process, the exact process of when you get to the pads, you're going to be assigned a pad manager. They're going to they'll have some detailed information about that. They'll talk about recovery. So you're not going to be allowed to go recover your rocket if you haven't done the recovery. I think they may even have a video or something now, a little training about stay together, keep within eyesight. They're going to issue you're not allowed to go in the recovery area without a radio on your person, right? That radio has a transmitter, bidirectional, so we can track where you are and come help you if you need help. But the radio is also for you to call for help if you need it, right? If you're lost, whatever, that's what that radio and the recovery group needs to stay together. And you need to take a lot of water with you. Those types of things that recovery team will tell you, as you're checking out. You have to check out. You can't just wander out and go get a rocket after it flies. You need to go check with the recovery guys, and then they'll let you go out there to recover. So those are the high points of the different sub processes and the things that will happen. There's a lot more to it as first time people, but the event will guide you through all of that from the check-in. They'll give you I think a packet, and then they'll tell you meeting times and things like that. So okay.
Okay.
All right.
Thank you.
You're welcome. Thanks, guys. Good luck. Rocket looks pretty good so far.
Thank you for sharing your time. Thank you for the recommendations.
Yep.
And I don't know what to say. I will say good night, but I guess it's afternoon in there.
Yeah,
so
it's afternoon. Good afternoon.
have a
Good
nice
night to you.
afternoon.
Yes. Good night to you, and take care. All right. Travel safe.
Take care. Thank
Right.
you.
See you.
Bye.
Bye.
Bye.
Bye.